6-point charges are placed at the vertices of a hexagon. All right. Uh, yes. So as you can see, hexagon of side length 1 meter. So here side length is 1 meter. Net electric field at the center of the hexagon is what? That is what we need to find. Okay, now you can solve
Okay.
this question, okay, by just looking at it. Okay.
Okay.
How many charges are there? 3 and 3. Both, I mean, all of them are equal, right? And
Yeah.
having opposite signs. Yes or no?
Yes.
So due to this, here the electric field would be in this direction. Due to this, electric field would be in this direction, and due to this, electric field would be in this direction. Yes or no?
Yeah.
Okay, now due to negative charges, here electric field would be in this direction, electric field would be in this direction, and in this direction. Yes or no?
Yeah.
If the force, I mean, the charges were same in magnitude, like all of them were negative or positive, then and then only electric field can be negative, right? Sorry, zero.
Yeah.
But here, as you can see, that's not the case. So here we need to find out the electric field. So first of all, due to all these charges, electric field would be E, right? Equal.
Yeah.
Okay. So let's write it is E, E, E. And that will be positive, right?
Yeah.
And due to this negative charge, here electric field would be minus E, and minus E, right?
Yeah.
So electric field is given by KQ divided by R, right? So due to
Yeah.
positive, it would be positive KQ upon R, and due to negative charge, it would be minus KQ divided by R, right?
Yeah.
Okay, so as you can see, they are cancelling each other, right?
Yeah.
So all these electric fields would cancel out each other, okay? So
Okay.
our assumption were wrong that since they are positive charges and they are negative charges, and we are getting electric fields in particular direction, so it should be not zero, but it is actually zero. So the answer would be zero. Okay.
Okay.
All right.
Yeah.
Now let's solve. Tell me what will be the answer for this 31st question. A proton and an alpha particle having equal kinetic energy
C.
are projected in a uniform transverse electric field as shown in figure. So first of all, you must understand that proton carries positive charge, right?
Yeah.
While alpha particle is a helium nucleus, okay, 2He4, right?
Hmm. Yeah.
So alpha particle will deflect or not.
Yeah. It will.
What's the charge of alpha particle?
Wait, no, but here it's not gonna be affected.
Hmm?
Like over here, it won't be deflected, right?
So let's say it is plus E charge for proton. So for alpha particles, it is plus 2E charge, okay?
Okay.
Now tell me what happened.
Um,
So let's say first a proton enters, okay?
okay.
So if proton enters from this side, sorry, from the center, we are projecting it, okay? So it will follow
Okay.
this type of trajectory, right? Since this is
Okay.
negative charges, right? So it will get attracted towards the negative charges. Now, as soon as you project a alpha particle, so they are more positively charged, right? So they will
Yeah.
experience more force, right? So its trajectory
Yeah.
will be more curved, okay, compared to proton. So answer is 2. Option 2. Alpha particle trajectory is more curved. Understood?
But so shouldn't it be C?
Why? As you can see,
Because they both are also in opposite.
alpha particle carries more charge. So according to this formula, Q multiplied by E, more the charge, more is the force, right?
Oh,
Okay. Now go for the
okay, okay.
32nd question.
Okay, okay, got it.
So electric field in a region is uniform and is given by this thing. E is equal to this. Electric field associated with the surface area is this.
Yeah,
So we need to find out flux, right? Flux is nothing
yeah,
but the dot product of electric field and area, right?
yeah.
So here tell me what it will be.
Um,
It's a dot product, okay? So electric field is
yeah,
A I cap plus B J cap plus C K cap multiplied by pi r square I cap. So remember in a dot product I cap dot I cap is 1 or J cap dot J cap is 1 or K cap dot K cap is 1. Otherwise all the things would be 0. So that means this term will survive, right? So it will be A multiplied by pi r square. That's the answer. Okay. All right. Jivika. All right. Now let's do this 33rd question.
okay.
An infinite line charge is at the axis of a cylinder of length 1 meter and radius 7 centimeter. This is our infinitely long charge and it is at the axis of a cylinder. Radius and length of this cylinder is given. Length is 1 meter and radius is 7 centimeter. Okay. Hello, Jivika. Hello. Start. So this is the situation. If the electric field at any point on the curved surface of cylinder, at any point, that means on this curved surface at r distance,
Okay.
and it is given as 250 Newton per coulomb. The net electric flux through the cylinder is what? We need to find a net electric flux. So net electric
Okay.
flux is given by Q by epsilon naught, right? Q
Yeah.
enclosed by epsilon naught, okay, not just Q. So here we need to find this enclosed charge. So how we are going to do it? So for this is a line charge, right?
Yeah.
So let's say lambda is equal to Q upon epsilon naught. Let's say this much length, this 1 meter length consists Q charge, okay? So that will be lambda into epsilon naught. Yes or no?
Yes.
First of all, due to cylinder, or you can say for the infinitely long wire. Remember the electric field at any distance r was given by 2k lambda upon r, yes or no?
Yeah.
So electric field is given, okay? This is 2 into 10, 9 into 10 raised to 9 divided by
Yeah.
radius, right? Radius is 7
7.
centimeters. So 7 into 10 raised to minus multiplied by lambda. So from here we can get the value of lambda, right?
Yeah.
Okay, so tell me what it will be. Calculate this thing,
Okay.
or right now just don't just let's just put this as a formula, okay? The value of lambda. We'll calculate all the things later.
Okay.
Okay, so from here lambda is ER divided by 2k. Okay, and our
Okay.
charge is Q into sorry Q upon length. It's this charge, right? That is the charge because it's a
Yeah.
linear charge density. So it will be lambda L.
Okay.
Okay, so here if you put this value, then you will end up with a charge as ER divided by 2k multiplied by L, right?
Yeah.
Now, according to Gauss law, flux is given by Q by epsilon naught. So this much charge is there, right? So
Yeah.
it will be E small r L upon 2k epsilon naught. Okay. Now, if you put all
Okay.
this value, you'll end up with the answer. Okay. So this is the
Okay.
way. So I'm not calculating it because it will take over too much time. Okay. Do it by
Okay.
yourself and confirm whether you get the answer or not.
Okay.
Now, this 34th question looks good, right? And a
Yeah.
bit dangerous. But always remember, dangerous the question by looking, easier is the solution. Okay? That's the
Okay.
formula for electrostatics and magnetism, or
Okay.
particularly in physics. So, a small conducting sphere is hanged by an insulating thread between the plates of a parallel plate capacitor. The net force on the sphere is. So, what will be the net force on this sphere? Alright, so this plate is positive, this plate is negative, right? So, this plate will have electric field which is minus sigma upon 2 epsilon 0. This plate is having electric field of plus sigma upon 2 epsilon 0, right?
Yeah.
So, this way it will experience force in both the directions, right? Which is
Yeah.
equal. Okay.
Okay.
So here answer should be 0, right?
Yeah. Because it cancels.
But what if we displace a little bit? Then what will happen? Think about it. So the net force on the conducting sphere is zero. So it was that much easy. Remember I told you that
Yeah.
dangerous the look of a question, easier the solution. So that's the key
Mm.
towards your
Okay.
IIT dream, right? Your engineering dream.
Yeah.
Now 35th question. Electric charge QQQ minus 2Q are placed at the corners of an equilateral triangle ABC. Okay, now I hope I can pull up a equilateral triangle from my tools, because right now this app is not properly working, but it's okay. Alright, so they gave us an equilateral triangle. Electric charges QQ and minus 2Q are placed at the corners of an equilateral triangle ABC of side L. The magnitude of electric dipole moment of the system is, let's say there is Q, and there is minus 2Q, okay?
Okay.
So as I told you earlier, the dangerous the look of a question, easier the solution. Now if the
Mm.
question looks easier, like in this question, as you can see, it looks easy, right?
Yeah.
But that's not the case here, okay?
Okay.
It takes an interesting turn, okay? So let me show you how.
Okay.
So here, as you can see, dipole, you know, right? Dipole moment is minus q into 2l, or charge into length, right?
Yeah.
Yes or no?
Yes.
Okay, but and for the dipole, there should be two equal charges. Yes or no?
Yeah.
But right now we only see two positive charges and one minus 2q charge. So what we can do, we can separate this minus 2q charge, right? We can do it this
Yeah.
way, that there is minus q charge and another minus q charge at the same time, at this same point, okay? So by that way we can
Okay.
make a dipole. See, this one is the first dipole. What's the direction of a dipole? Is it negative to positive or positive to negative?
Positive to negative to positive.
Okay, so first dipole moment is in this direction and the second one is in this direction, right?
Yeah.
So they are making an angle how much? 60-degree with each other, yes or no?
Yes.
So now this question becomes merely of a question from vector algebra, right? Two vectors are making an angle 60-degree with each other, yes or no? And we
Yeah.
need to find their resultant. So how to find the resultant? It is simple, under root. Remember a square plus b square plus 2ab cos theta. So that way
Yeah.
it will be 2pp cos 60-degree. Now p square plus p square is 2p square. This is also 2p square, and cos 60-degree is 1 half. So this will be 3p square. The answer would be under root 3p. P is q into L. That is the answer. Option number 3. Okay.
Okay.
You like this question or what?
Yeah. It was simple.
Okay. Now these questions seems easy. Let's take this 45th question. Okay, because it looks dangerous,
Okay.
but remember what I told you.
Yeah.
The given figure shows two parallel plate capacitors A and B. Sorry, two plates A and B. Okay. Of charges, charge density plus sigma and minus sigma. This is region 1, 2 and 3. Electric field intensity will be 0 in region what? In what region electric field would be 0? So remember, this is forming a capacitor, right? So electric field will only exist in this region, okay?
Okay.
So electric field intensity will be 0 in this region and this is region, okay? The answer would be 1 and 3 only. So option here option would be both 1 and 3, right?
Oh, yeah.
Understood?
Yeah.
Very good. Now let's go for another question. So see, this question number 46 looks easy, but I think it will be difficult. A sphere of radius r has a uniform distribution of electric charge in its volume. Okay. At a distance x from its center. At a distance x from its center. The electric field is directly proportional to what? So remember I told you this charge has a uniform distribution. Okay, so charge is everywhere. So remember I told you
Okay.
that the electric field inside a uh, sphere where the charge distribution is uniform, the electric field inside of it is given by rho r upon 3 epsilon 0. Okay, here in this
Yeah.
case, this distance is x. So here, electric field is directly proportional to this. You can find out by Gauss's law. Okay, like
Okay.
first you are going to so first you are going to assume that the charge density is q by v. Okay, now total charge is
Okay.
let's say q. Then you are going to assume that here the charge is q1. Okay, so you need to find out this q1 charge. That would be q1 by volume. It would be q1 rho v, and you can use Gauss's law and get this electric field as your answer. I even solved this question on my YouTube channel. You can find out that video on my channel. Okay.
Okay.
Okay. The electric field at 20 centimeter from the center of uniformly charged non-conducting sphere. Again, same question. See, at 20 centimeter, it is uniformly non-conducting charge. Okay, so at r distance, electric field is given by rho r over 3 epsilon naught, and that is given, right?
Okay.
Sphere of radius 10 centimeter. The electric field at 20 centimeter from the center of a uniformly charged non-conducting sphere of radius 10 centimeter. So they are actually telling us that that outside point, right? Because the radius of
Yeah.
this sphere is only 10 centimeter. So at 20 centimeter, electric field is E. So we are this formula is not valid. Okay, this is only for inside distance. Okay.
Okay.
Then for equilibrium of a sphere, the surface charge density of the plate is what? Sorry, that is question number 48, right? We are right now on
Yeah.
47. Then at a distance 5 centimeter from the center, it will be. So at the center, at x distance, electric field is rho x by 3 epsilon 0, right?
Yeah.
So what do we need here? Electric field is given, we have this radius, right? Let's call it E1, okay? All right. So we don't know what is rho, right? So we can find out by using this electric field, which is at 20 centimeter, right?
Okay.
So let's say its charge is Q, okay? And we can define Q as rho V. So due to this charge at 20 centimeter distance, or you can say at capital or R1 distance, electric field is simply KQ divided by R1 square, right? Yes or
Yeah.
no? Now
Yeah.
this is K and Q is rho V divided by R1 square. That means 20 square. That is 400 multiplied by centimeter square, that would be minus 4, right? So it will eventually k rho v divided by 4 into 10 raised to minus. Yes or no?
Yeah.
So from here, this k rho v is 4 into 10 raised to minus 2 into e. Okay. So from here, this rho v is given by 4 into 10 raised to minus 2 into e divided by k, right?
Yeah.
Now we can use this thing, see this rho v thing. Okay. How? Because we can find out the charge. Here this charge is q1. Okay.
Okay.
Okay. And the density, or you can plug this value directly here. Okay. By putting volume, which
Okay.
is 4 by 3 pi r cube, right? Here r is 10
Yeah.
centimeter. Okay. You will get some
Okay.
value, right? If you plug this here, you will get rho value. Now if you plug
Yeah.
this rho value here, you have this x distance, that is how much? 5 centimeter, as it says in this question.
Yeah.
So you'll end up with the answer. Okay.
Okay.
I'm not solving it again. Okay.
Yeah. Okay.
You get an idea, right?
Yeah.